Hello everyone, and welcome back to my channel. This is Vishnu Ranjipudi, and I am glad that you are here. Today, we will be solving problem numbers 11 through 15 of the 2019 AMC8. So let's begin with problem number 11. The problem reads, the 8th grade class, so 8th grade, we might need to remember that, has 93 students. So the 8th grade class has 93 students. Each student takes either a math class, foreign language class, or both. So already right off the bat, we're starting to see that this looks a lot like a principle of inclusion-exclusion problem, since you can take one, the other, or both. There are 70 8th graders, so 70 taking math, and 54 taking a foreign language class. So how many take only math and not foreign language? Now, it turns out that 8th grade wasn't really relevant, and we can just use the principle of inclusion-exclusion. So, the principle of inclusion-exclusion states that the total number, which is 93, is equal to the number in math, which is 70. So 70 plus the number of the other one, which is foreign language, so 54, minus both. So let's just let B denote both. So here we can just solve this equation for B to get that B is equal to 31. And now that we know B, we can just find out the number that only take math by subtracting B from 70. And 70 minus B is just 39, which is choice D. So 70 minus B is equal to 30. And now let's move on to problem number 12. So let's begin. Problem 12. The faces of a cube are painted in 6 different colors: red, white, green, brown, aqua, and purple. 3 views of the cube are shown below. What is the color of the face opposite the aqua face? So this is an example of a spatial visualization problem. So here, let's just imagine the rotations when we go from one figure to another. So let's imagine if we go from the first to the second. Okay, so from the first to the second, we can see that the blue is rotated this way. And we can also see that the red moves to this face. So it's all assuming that the entire cube moves this way. And the green also moves here. So that means in this photo, if we just draw the back, we know that this back is the green. So we already know that white is opposite of green. So now, we know that white and green can't be opposite aqua, so not B or C. Alright, and now let's look at the second image to the third image. Well, there doesn't seem to be an obvious connection. So instead, let's look at the first to the third image. Well, if from the first image to the third image, it looks like we can just rotate this up. Well, I need to just do it on here. We can rotate this downwards, because that will also rotate this way. And then we get our original cube. So if we just uncover what is on that face, we see that purple is opposite blue. Since in this transformation, if we do this, we know that this side is blue. I'm sorry, brown. All the times when I said blue, I meant brown. So, yeah, which means that purple is opposite brown. We already know that green is opposite white. So thus, aqua must be opposite red. Okay, and we're done with this problem. Let's move on to problem number 13. A palindrome is a number which has the same value when read from left to right or from right to left. For example, 12321 is a palindrome. Let n be the least 3-digit integer which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? So we want the least 3-digit number, right? Well, the only 2-digit palindromes are the multiples of 11. So we have like 1, 1, 2, 2, dot, 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 9, 9. Which means that their sum is also a multiple of 11. And the lowest multiple of 11 greater than 100 is 110. So let's check if these palindromes can sum to 110. They indeed can if we have 11, 22, and 77. That's just one example. Many will work. So that means that the sum of the digits is 2, which is A. Let's move on. Alright, problem 14. Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she will redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realizes that no circled date falls on a Sunday. On what day of the week does Isabella redeem her first coupon? So, we know that she redeems one every 10 days. And Pete's, she never lands on Sunday. However, that means that on the 7th day, if she goes 7 days, then she'd land on a Sunday. So, that means that we can use mods to find out our answer. So, a mod is just a remainder when you divide by a number. In this case, we'll take mod 7. So, let the first day be D. Okay, the second day will be D plus 3, since we just cancel out one of the weeks. Then the next one will be D plus 6. The next one will be D plus 9, which is also D plus 2. This one can also be written as D minus 1 if we have to. Then the next one is D plus 5, or D minus 2. And the next one after this is D plus 1. And then finally we have D plus 4. And now since she doesn't land on a Sunday, that means that none of these circle dates land on a Sunday, which means that this date must land on a Sunday, since all of them are distinct mod 7. So thus we have D plus 4 equals Sunday. Okay, and we'll let Monday be equal to 0. So if Monday is equal to 0, that means Sunday is equal to 6, which means D is equal to 2, and 2 is equal to Wednesday. So we are done with this problem. Now let's go to the final problem. Problem number 15. On a beach, 50 people are wearing caps. 50 people are wearing sunglasses, and 35 people are wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses is 2/5. If instead someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? Now, this is just elementary probability. So, we can just use a combination of probability and pi. So, you know that the probability of a person wearing a cap and wearing a sunglasses is 2/5. So, since we're given that 35 people are wearing caps, that means that 2/5 of them, or 14 of the people wearing caps, wear sunglasses, which means 14 people wear both. So, now that we have 14 people who wear both, now if we check someone wearing sunglasses, there's 50 people, we still have 14 both, so our answer is 14 over 50, which is equal to 7 over 25, which is choice B, and we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below or email me at steamaspirations@gmail.com. Once again, this is Vishnu Manjipudi, signing off. Bye!